In many ways, the deep sea is the final frontier for life on Earth. But new technologies are opening up the depths like never before, and extraordinary discoveries are pouring out. The latest of these new finds is the deepest and possibly the hottest undersea volcanic vents on the planet. And despite being 5 kilometres down, these vents are covered in life. Hello, I'm Helen Scales, and in this special edition of The Naked Scientists, I talk to the people who found those record-breaking vents. John Copley and Douglas Connolly from the National Oceanography Centre in Southampton took a team to the Cayman Trough, which gouges a gigantic trench in the seafloor, miles down beneath the waves in the Caribbean Sea. It was there that the team detected a vast plume of scorching, mineral-laden water reaching a kilometre up into the water column. Here's geochemist Douglas Connolly.
Cayman Trough was identified quite a while ago as one of the interesting sort of missing pieces of the global reef systems. It's isolated, sits on its own, and it's also one of the deepest places and one of the slowest spreading. It had been postulated that there wouldn't be any venting activity there at all. Basically, activity is dependent upon the spreading rate, is one of the old models that was out there. In the deep side, we've got extremely high pressure and perhaps the existence of supercritical fluids.
These supercritical fluids behave very strangely under the laws of physics. They're lighter than water but denser than vapour. And the team think these extremely deep vents, which they've called the BB vent field after the first scientists who explored the deep ocean, could be one of the only places on the planet to study these fluids in a natural setting, including their specific effect on the way minerals are leached out of rocks. Connolly and his colleagues found unusually high concentrations of copper in the fluids rising up from the vent, which indicates the presence of these supercritical fluids, and along with the height of the vent plume, 4 times higher than at any other deep-sea vents, this suggests that the water could be as hot as 450 degrees Celsius. And despite the enormous pressure, life down there is thriving, as the team discovered by sending down a robotic submarine to take a look. Here's marine biologist John Copley.
Well, for biologists, we've wanted to go and explore the Cayman Trough for deep-sea vents for nearly a decade because we thought it might be a key missing piece in a global jigsaw puzzle. What was a surprise was actually, yes, we've seen new species of shrimp down there. There may be a new species of anemone at the deepest site in their hundreds around these sort of cracks that seep warm water from the seafloor. But these are very similar to animals that we know, but from a long way away, 2,500 miles away in the Atlantic. And it suggests there's a lot more traffic. Animals are getting around in the deep ocean, perhaps a lot more than we thought before.
Another world first came from this study, which was the unexpected discovery of a hot vent in a much shallower site on the upper slopes of an undersea mountain called Mount Dent. This sticks 3 kilometres above the Cayman Trough, although its peak is still 2 kilometres beneath the waves.
What was fascinating about finding this shallow site on Mount Dent, the site we've called the Von Dam vent field, is that it was in a place where we simply normally wouldn't look. We wouldn't normally expect to see hot, acidic vents that support a rich colony of deep-sea life, so far from the heart of the volcanic rift. Now, people have seen types of deep-sea vents away from the heart of volcanic rifts before, but they've not been the same in chemistry. They've been cooler, they've been alkaline, and they don't provide a home for rich colonies of animals. So finding this sort of additional colony up on this undersea mountain, which is we think that the kind of undersea mountains that Mount Dent is, we think they might be quite common around the world's oceans. So if we can get hot venting there on Mount Dent, maybe there are hot vents on other similar undersea mountains around the world. Maybe there are a lot more sort of way stations, a lot more colonies of deep-sea animals at vents than we thought before. And that actually, that starts to make sense, because when we do go to vents and we do the genetics on the populations of creatures there, we often get these sort of estimates that the size of their population is probably a lot bigger than all the animals we're seeing at that site. And that suggests that, hey, maybe there may be more sites and more colonies out there than we realised.
And by all accounts, finding the world's deepest known vents was an exciting and quite an emotional time. Here's Doug Connolly.
Very, very emotional. There were peers in the laboratory, I won't say whom, but it was an absolute great evening. We'd been exploring for hours and hours and hours on both of these vent sites, and when you're in the deep sea, you go across basically sedimented, unexciting areas where there's lots of sediment and just old pillow lavas, and then all of a sudden you find this sort of areas where there's an explosion of life, and just it literally is an oasis, a little sort of an area with just totally different to the area around it, and it was extremely emotional.
Well, the exciting news is that another research team led by the Woods Hole Oceanographic Institute in the US is back out at the Cayman Trough.
Right now, our American colleagues are out there on an expedition with another deep diving vehicle, and some of our UK team are out there working with them. We're hoping that they'll get the first direct measurement of temperature to see if our calculations and estimates that these are extremely hot vents turn out to be right. And as a biologist, we're waiting to see what other animals turn up. When you first go there for a look-see, you notice and you're able to collect the most obvious abundant animals, but there's often some surprises, sort of hiding behind them. So it's always fascinating to find out what other creatures are going to be down there. At the shallow site, away from the shallow site, we found white tubes on the seafloor that we thought might have come from tube worms, animals known from deep-sea vents in the Pacific, also known from other little islands of life called cold seeps, a bit to the north in the Gulf of Mexico. We couldn't tell whether they were alive or dead. They looked very pristine, white and fresh, so if they were dead, they hadn't been dead for long. And another American expedition, which was only able to explore with a camera system back in August last year, showed that these were actually live tube worms. But until we get some specimens and we get them back to the lab, we can't tell what they're related to. Is there also a link to the Pacific? Is there a link to the Gulf of Mexico? We're trying to understand this crossroads in the deep ocean.
So exciting. It is just the cutting edge of marine science right now, because it's all new, and it seems like every week now there's new deep sea vent papers getting published. It's fantastic. It must be a very exciting field to find yourself in the middle of, I guess. So
it's a great time to be a deep sea scientist. We're getting out there deeper and for longer and more often than ever before. And there's still a lot left to see. Half of our planet's covered by water that's more than 2 miles deep, so it's going to keep us busy, hopefully, for lifetimes to come.
Absolutely. And I guess the reason that's the case is that we are really breaking through technologies and that it's becoming cheaper and more accessible to do these things and to get down to these depths.
Yeah, we're completely dependent on the ingenuity of engineers who design, build and operate our deep-sea vehicles, and it's only been in the latter half of the 20th century that we really developed the technology to get into the deep ocean and to see what's down there directly and to explore the ocean floor. I mean, I've been working in the deep ocean for 15 years or so now, and I've seen big changes in technology in that time. When I started, manned submersibles were the way that we visited the ocean floor and did this work. Now we're using these remote vehicles, and in many ways they're more flexible, they allow us to do more, and they're as good as being on the ocean floor. They're our eyes and arms for working down there. And then we've got things like the robot submarine that we used, AutoSub 6000, which isn't remote controlled, it's pre-programmed. And so we've now got this fantastic sort of toolbox of technology that we can use to explore more.
So I guess it's a little bit like, do we send people to the moon anymore? Well, no, we can just send probes and things to do it for us. Same thing for the deep sea stuff. Although I guess there's still, I don't know, do you feel like being down there yourself is something else as well? I mean, have you been? How deep have you been down in it?
I have. I've been to vents 2,200 meters deep in the Pacific,
wow.
And that was actually right at the start of my career. And it's a difficult one. Yes, I have to admit that actually being there, it gives you a real sense of the environment. I mean, as a biologist, the thing I notice is how patchy it is. How there are little clumps of creatures here and there, and it's a real patchwork. And that's because the conditions are so variable. And that's actually really important to grasp, to understand the system as a biologist. But that said, these days, the remotely operated vehicles allow us to do things the manned submersibles couldn't. We can actually get really detailed pictures of what's down there because we have incredibly precise control over the remote vehicles. They're a lot smaller. So it's difficult. My current students, of course, all itching to make manned submersible dives, which is quite rare these days. But at the same time, they're actually able to see things that we couldn't see previously with manned subs.
That was John Copley and also Doug Connolly from the National Oceanography Centre in Southampton talking to me, Helen Scales, about their discovery of the world's deepest deep-sea vents and how technology is opening up the depths like never before. You can find out more about the deep sea at the Naked Scientists web pages dedicated to ocean science. Every month in the Naked Oceans podcast, we dive beneath the waves to bring you the very latest marine science and conservation, from seagrass to sunfish, dugongs to diatoms. You can find all that at thenakedscientist.com/oceans. Thanks for listening and catch you next time.